We're going to go in there this morning. As Danielle talked about, we're going to talk about some services that PMC offers and different tools that we can utilize to help your production and increase your efficiencies in your site. First, PMC is an engineering manufacturing consulting firm. We're a full-service industrial engineering and IT consulting firm providing process improvement services and software to manufacturing and service industries. Utilize a solid mix of experience, knowledge, and creativity. We always find ways to improve the quality, the efficiency, and the productivity of the manufacturing and the service industries. Some of our specialties in our consulting services include advanced manufacturing, material handling, supply chain management, facility layout and design, CAD services, industrial engineering and lean manufacturing, simulation modeling, program and project management. We also offer staffing and training services. We offer training in CAD, simulation, and MODAPs, and many other services if you're interested. In our advanced manufacturing and engineering, our expertise in industrial engineering and work measurement, the labor analysis and scheduling, ergonomic studies, Six Sigma, line balancing, and layout analysis. In the simulation area, we include increased throughput, capacity verification, enterprise profit model, waste reduction, constraint management, work in process inventory, and direct and indirect labor utilizations. We also go into lean manufacturing where we standardize work, process system simulation, value stream mapping, workplace design, and ergonomics. Also looking at workplace organization, better known as 5S, additionally 5T to that, waste reduction, the 7 wastes, SPC error and mistake proofing, visual management, problem solving, and team concept. Additionally, we do material handling. We look at material handling density analysis, resource allocation, production planning, flow and process management, inventory management, indirect labor optimization, Kanban optimization, and material display and part presentations. In the digital engineering area, we get CAD services including installation drawings, layouts, scanning, and conversion. We even go further into that. If there's more information you would like, please contact us. We do 2D and 3D design in digital engineering. In supply chain management and advanced planning and scheduling and network optimization, risk management, finite capacity scheduling, inventory reduction, project timeline and cost reduction, and material flow and layout optimization. Talk a little more about the production control and the material handling engineering. We look at the layout. We look at the overall layout showing a warehouse. We'll show the staging areas, the routing, and the aisleways, any monuments and docks and additional items that are within your warehouse. Detailed layout diagram, 2D layout, including stations and assembly lines. We look at a station-by-station line display, which includes the material and also the equipment that the material is laid upon. The summary of the material handling equipment requirement is a vital part of what we also do. We can show you and better right-size your fleet. We do a static dock analysis for future state dock analysis, including labeling and inbound and outbound. We look at all this in order to ensure that you have the proper amount of dock space, or to look to see if we need to add additional space or to redesign the area a little bit differently. We also look at a storage analysis outside of the docks for future state storage space requirements, such as small lots, bulk, staging, empty racks, and finished engines, if that's the case. In the material flow area, we look at the part delivery sequence. We can optimize the sequencing of the fork trucks and or the tuggers, or even just the hand delivery of parts. We can better minimize the dollar spent to support the projects. We look at aisle congestion. We look at it in a static dynamic type, or a static stimulation type study. We also look at the material handling equipment and the manpower required and a better way to optimize that. In the industrial engineering area, we look at different types of work measurements such as MODAPs, MOST, and time and motion studies. Those three right there are different forms of calculating the amount of time it takes to do a particular task or many tasks, or possibly even looking at the overall operation of your plant or your operation. We do a labor analysis, we do labor scheduling, and we also look at workstation design and optimization, as we talked about before. We like to concentrate in the ergonomics and the Six Sigma areas also. So a little more on the material handling. In the material handling, we usually start out building a PFEP database. PFEP stands for Plan for Every Part. And we'll go further into exactly what a PFEP database is in the next few slides. We also really concentrate on the material display, ensuring that we optimize all that, which will be further looked upon. We look at the kitting, the sequencing, and sub-assembly area design, sometimes called cells. We look at the delivery route design and workload balancing to ensure that the fork trucks and or the people all have optimal workloads. We try to keep the workload at the 90 to 92% range. We look at dock and storage analysis, as we mentioned, and engineering and visualization services. We'll look at laser scanning and 3D modeling. We'll also take a look at some F&E equipment, facilities and equipment, that is, looking at special containers and new orders. In the plan for every part, the PFEP, some of the information that you might see in it is part data, which consists of part number, a part name, a part description, program, the variation, the part weight. We look at supplier data. We look at containerization data. We also look at any sub-data, subassembly data, such as the delivery route, the delivery method, supplier container number, and the location that will be used. And we'll take a look at the final assembly data. All this information is put onto one spreadsheet or one database, depending on what you prefer, so that it can be used by each and every department rather than every department having their own little category. In a material display, we look at every area of the material display and how it's laid out. This slide right here shows a couple different things that we'll be pointing out to you. If we can show the material display and we can optimize the material display, we can add additional room to the assembly line or the production line, that is. By minimizing the amount of space utilized, we can maximize the safety and also maximize the golden zone, which we'll talk about a little bit more. We minimize material handling by eliminating MREs, which are difficult and unnatural operations, also MURAs, irregular operations, and MUDAs. By doing all this, it automatically improves the workplace ergonomics. In the material display, some of the methods that we'll use to optimize everything is a single pick point or even a single pick face. We use different pieces of equipment such as H turntables, gravity flow racks, ensuring that we're always within the golden zone. We'll even use kitting, risers, and ergonomic platforms as required. Some of the material flow logistic guidelines that we follow is we always present parts in the golden zone. You might be asking, what is a golden zone? A golden zone is an area directly in front of the operator, an area where they don't have to turn around, where they utilize minimal amount of movement in order to put the parts to the line or put the object to where it belongs. This might be a better way to say that, thereby never having to turn around if possible and not having to reach too far or take steps in order to do it. We can minimize the amount of time it takes to actually do the task, thereby speeding up the production. We always optimize the delivery routes by maximizing utilization of the material flow and the assets. And we minimize your inventory. Inventory is an extremely expensive concept and it takes up a lot of floor space. So if we can minimize it, we can give you additional room to bring on additional work and add additional customers. We look at the standard flow of the products, we look at the information, the equipment, and even the people by optimizing each and every one of them. The delivery route design and workload balance, the objectives are to reduce the indirect labor, to standardize the delivery procedure, to reduce material handling equipment and investment, and reduce aisle traffic congestion. If you take a look at the examples that we have, you can look at the example of tugger routes and the example next to it of actually the before and after of the routes. Thereby, we actually eliminated one complete fork truck and also driver. The savings could come out to hundreds of thousands of dollars in a year, depending on the type of equipment you're using. One of the big things, ways that we reduce all this is by looking at kitting, sequencing, and sub-assembly cells. The question might be, why do I kit? Well, you kit for productivity purposes. It minimizes the movement of the operators, it places all the parts always in a golden zone. The quality is increased, you minimize the risk of assembling the wrong parts and additional rework costs. It's very flexible, minimize cycle variation and build mixes. You can also compress the line, as we talked a little bit about before, thereby allowing you to place parts to the proper area in a proper cell. It's also easier to learn. It's very easy to learn how to kit and how to do it, so it gives better working conditions and gives easier training. Now there are 3 different types of cells that are very confusing. There's kitting, there's sequencing, and there's subassembly cells. Now though they're all very similar, they are actually different, and that needs to be kept in mind as to what you're doing. If you look online, there's additional webinars that relate directly to these. That dock and storage analysis, the objectives of that is determining the dock and the storage utilization. We minimize the trailer waiting time. We minimize the space needed for storage. If you look to the right, you can see an example of a storage analysis and the amount of space that we were able to save and the way we were able to do all that. Talked a little bit about the facilities and the equipment thereof. Some of the equipment that we might use AGCs, we might use AGVs. We may even just build our own little cart. As you look around to the right side, you can see them. Whatever we have to do to maximize the efficiencies of the material flow and the presentation is what we'll do. We have the ability to build our carts. We have the ability to design them and get them sent out and to bring back the pricing to the customer in a no-stress manner. Let's talk a little bit about 3D scanning and 3D factory services and digitizing reality. See a couple pictures down below. These are actual pictures of a scan. They look like just standard pictures. However, they're not. These are actually within CAD and are all very measurable, just as you would do on a 2D CAD display. You might ask, why do we scan? Well, how do we scan? We scan over 100,000 square feet of manufacturing facilities in a day. We're experienced in Autodesk, Factory Design Suite, and Siemens Factory CAD. We're more than just scanning in CAD. PMC employees on average have more than 5 years experience in manufacturing plants. So we know the plants very well, thereby we can work very safely. We've done dozens of completed factories and hundreds of small projects that have been completed by PMC employees. Over to the left here on the picture, you'll see the little tripod with what looks like a large video camera. This is the actual scanner that we'll be using to come in and do the scanning. Over to the right, you can see a black and white scan of a robot cell. As we stated before, this is all in 3D. If we were using the software that we spoke about earlier, we'd be able to manipulate all this. We'd be able to move any object that we wanted to move and place it wherever we wanted to place it. We can measure it, and we can turn it, and we can look at every angle of it. This shows a little bit about the scanning history and where it started back in 2008 and how many scans per day a scanner could possibly do. If you see, back in 2008, we could only do about 24 scans a day. As compared to now, we can do up to 185 scans a day, which really decreases the cost to the end user. So why should we scan now? Well, as we just talked about, it's really no longer an experiment. The cost is lower. It's easier to capture and convert and use. We can do it without placing targets all over the plant. We can do a cloud to CAD conversions. It's not always required, but we can do it. And it's native support in existing CAD applications. That is to say, we can lay it right over top of your existing layout. Over to the right, you'll see the same robot cell. However, this time you'll see it in a color display. Once again, this is a 3D layout. So everything can be grabbed and manipulated and measured just as you would in your standard 2D CAD. Over to the right, you'll see a little video movement of a fly-through of the plant utilizing the 3D scan. I'll play it again. Now, although this clip is very short, it can be extremely long also. We can do this fly-through throughout your entire plant, which is very helpful when doing presentations in an office to executive management. It reduces the time on site for any inspections. Once again, like we said, we can capture 100,000 square feet a day or more. The accuracy is undisputed. We can get down to 1/8 of an inch accuracy. It's got the ability to view, measure by anyone, anytime, even during the meeting, as we just said. The data acquired has multiple uses and multiple sharing capabilities. It has an enabler to change or shorten the design process. PMC has been modeling 3D factories for over 15 years. We have millions of square feet modeled, and we're a highly effective offshore team, which enables us to reduce the cost to the end user. Looking below, once again, this is another 3D layout. Some of the history of 3D factory. Back in 2000, we began the development of the 3D factory with an initiative with General Motors. We did a strategic relationship developed with Factory CAD. We began working with the laser scan data in CAD and kicked off projects at Ford and Toyota and 3D factories. We converted a dozen assembly plants, developed a library of smart factory objects, which now will decrease the cost to an additional end user because we can use some of those objects to do your layouts. Working with Autodesk to develop factory design suite. We began 3D factory work with Mercedes and Chrysler. Now in 2015, we extend the 3D initiatives to the Tier 1s and the Tier 2 suppliers. We launched an R&D project to integrate live factory floor data into the virtual model, which is something we just looked at in the video. Virtual design and construction. When we combine scanning, 3D factory, and the knowledge of how to take the project from the beginning to the end, amazing things can happen, as you can see below. This, once again, is a 3D layout. You can see here where an oven was going to be placed within a factory, and it was difficult to figure where this oven was going to go and how to even bring it in. Utilizing the 3D factory, we were able to carry the oven through the factory and actually put it into place without having to remove any portions of the roof. Major cost savings to the end user. Here we can see some ductwork where it's being put it into the rafters, and you can see where we're going to have some deflection and where we might have to move something, where we may have to cut some, or we may have to even change where the ductwork is going to go. So we can pre-plan and we can follow our plans exactly, thereby eliminating any rework. Speaking of rework, if we take a look at where we started, back with traditional 2D layouts, you can see the initial base cost of a contract. Looking next to it, you can see what the field order ended up being. Adding those two together, the cost is nearly doubled. As we moved on, we were able to reduce a little bit of the base cost and reduce a little bit of the rework. And getting further on, you can see that the rework is going down even further. Now, with the advancement of the 3D factory CAD, we can bring the rework down to nearly 0%. I think we're probably looking at 2% here, looking at that number. Some of the typical challenges in manufacturing that we specifically address that we can adapt quickly to growing and fluctuating demands, the over and underutilization of resources, batch sizing and sequencing of systems with product mix issues. We can look at a large WIP area, work in process, evaluating systems for readiness for new product introduction. We can quantify the impact of the operational uncertainties such as downtimes. Evaluating facility expansion proposals. We can control the logic validation and frequent material shortages and line stoppages and frequent overtime costs. We do this by looking at simulation modeling and analysis. The simulation modeling analysis mimics the operation of a real system through time. Statistic distributions to capture the system variability. We can use what-if analysis, giving us KPI quantifications, operation strategy, decision making, and all this is done in a computer graphics for visualization purposes. Over on the left you can see the order in which we do this. We look at a scope and the objective, we go through the data collection and the model building, we look at a verification process and a validation process, then we do an analysis. Then we begin to do the what-ifs and experimentation area, and we come back with our reporting to you. Some of the value added with simulation is from the conceptual phase, from the layout to design validation, with the capital investment analysis, and the process flow design. In the build phase, material flow analysis, labor requirement study, sensitivity analysis, and model mix. In the operational phase, we look at a line-side delivery improvement, resource optimization analysis, and new model introduction, the study and the impact and the variability. We offer several different types of software to do this, and over on the right you'll see we use Simulate, we can use AutoMod, Witness, Enterprise Dynamics, Extendism, ProMod, etc. We also offer all these services and softwares for sale. So why dynamic simulation? Leverage the what-if scenarios to accurately estimate minimum indirect labor staffing levels to support production. Identify and eliminate the excess inventory on line side as well as in the marketplace. To identify and eliminate the risk and efficiencies in material flow design early in the program. And we also provide the 3D animation, the material flow design, to the key stakeholders and to facilitate the communications. And we create a robust design by considering dynamic interactions between the systems and entities based on the current and future needs. So what we're basically saying is we can actually look at the future and tell you what you're going to need if the data that we're being given is correct. Dynamic simulation creates a dynamic view of the material flow. It's actually within 3D. Once again, you can take a look at the view that you'll actually be seeing. If you can look close enough, you can see that the tuggers that are being used within this example right here actually even have drivers on them. You can see the flow and how everything's moving through the entire plant. It uses distance, cost, and time variation to develop optimal conditions. It includes the dynamic interactions, which leads to the optimum and lower safety factors. Optimizes line side inventory levels based on actual dynamics in the operation. Now, I would like to say one thing. We are talking about simulation within a material movement. However, I do not want anybody to think that simulation is only used in materials. So simulation can be used in nearly any event, from looking at the traffic on a road to looking at the human traffic within a stadium possibly. Even looking at how to operate a kitchen area or a bank. So there is really very little limitations to where simulation can take us. So I present all this. Why PMC? Well, we have a vast domain of knowledge of the automobile industry. We have 30 plus years of experience. We've done well over 6,000 projects. We have a large global team for a faster turnaround of projects. Some of our team could be working on the projects while you're sleeping at night. When you wake up in the morning, it's possible that we'll have the project completed and in your inbox. We have comprehensive offerings of industrial engineering services, and we have a large hands-on experience of the consulting and implementation and training. Here you'll see a partial list, just a small partial list of some of the clients that we've done in the past. I won't read all these, however, I'll leave it on the screen for a second for everybody to take in.